This video is about areas of composite figures. Composite figures are basically where we combine known shapes into shapes that we don't know how to find the area of. But because that's the case, then we have to use the known shapes to find the area of the unknown shape. So let's just take a look at three quick examples. We're going to find the area of this thing. So we want the area of this entire shape. In this case, we appear to have three different things going on. We appear to have a semicircle. We appear to have a rectangle. And we appear to have a triangle. So we're going to do those three things and then add them all together. So the semicircle, well, since this is a rectangle, that's also 18. And the radius will be 9 because that represents the diameter, that 18. So the semicircle is going to be, the area of the semicircle is pi times 9 squared. And then divide that by 2 or multiply it by 1/2 because it's half of a circle. So this is the area of a circle, pi r squared, and then we divide it by 2 or multiply it by 1/2. So this ends up being 81 pi over 2, which is about 127.235 units squared. Now so that's the area of the semicircle. Now we're going to add that to the area of the rectangle. A rectangle's area is pretty straightforward. That's just base times height. So we have 18 times 7, and that gives us 126. Then we're going to add that to this triangle. The area of a triangle is 1/2 base times height. So the base is 18, and the height was given as 10. So 1/2 times 18 times 10 gives us 90. So all I have to do is add these three things together, and I will get the answer. So if I wanted the answer in exact form, I would say it was 81 pi over 2 plus 216, because these two numbers add to 216. If I just typed this in the calculator where I added all these three things together, I would get a rounded decimal. So I would have 343.235 units squared. That represents the area of this first composite figure. Now the second figure, I'm going to break this up. This is a little bit more confusing, but I'm going to break this up into essentially two parts, and then each of those parts has two parts to go along with it. So if we look at this entire figure, it's kind of like one giant rectangle, 40 by 32. So I could break this up into a giant rectangle and then subtract the triangle, this rectangle, and this semicircle. I could do it that way, and that's not a problem. That's not how I did it when I already did the problem. But if you did big rectangle, and then so big entire rectangle, and then subtract those three things that I just said, you would get the correct answer. There are many ways that you can get the correct answer in this problem, and it would be totally fine. But I'm going to show you one way, the way that I saw it when I originally looked at the problem. So what I originally saw was I saw a rectangle on the top and a rectangle on the bottom. So I'm just treating it like it's a big kind of a medium-sized rectangle up here and a smaller rectangle here. And then I have to subtract this triangle and subtract this semicircle. So if I do those things, then I end up with just the area of the figure that I want to have. So in order to do that, I'm going to do 4 parts to this problem. Part 1 is this rectangle up here that has a length of 40 and a height of 24. So I'll call that bigger rectangle. That's 40 times 24, and that ends up being 960. Then I have this triangle that I have to subtract. So in order to get the area of that triangle, I have to figure out what this length is. Well, if the whole thing is 40 and this part is 22, then I have to do 40 minus 22 to get that length, which is 18. So the triangle is 1/2 times 18 times 9 for that area. So the area of the triangle is 81. So I'm going to have 960, and I have to subtract 81. Now, I'm going to take a look at this rectangle. We know that this is 12. One thing to note, if this is 22 and this is 12, that adds up to 34, which is not 40. So we can't assume that these two connect, and they actually don't. So that's something that's kind of important because there would be some missing gaps in the middle of that. So now what I have to do is this is 12, this whole thing is 24, and this part, I'm sorry, the whole thing is 32, and this part is 24. So what that means is the part that's missing on the other side has to be 8. So we can do that subtraction because we know that 32 and 24 does 24 plus whatever's missing does have to equal 32. But we cannot just assume that 22 and 12 makes up the entire thing for the horizontal part of the line. So I know that this is 8 and this is 12. So the area of the smaller rectangle, I'll call it, is 8 times 12, which is 96. Now I have to subtract this semicircle. So then I will just end up with the rectangle minus the triangle, and then the smaller rectangle minus the semicircle. So the semicircle is pi times, well, the radius of this, I have to figure out the radius. If this is 8, the radius must be 4, because the diameter being 8 means the radius is 4. So pi times 4 squared divided by 2 gives me 8 pi. 8 pi is about 25.133. So I'm now just going to add together everything over here. 960 minus this triangle, so minus 81. That gets me the part on top that's inside the shape. And then I'm going to add 96, and I'm going to subtract 25.133. And when I'm all done with that, or that's 8 pi basically. So when I'm all done with that, I end up with 975 minus 8 pi as the exact answer. And the rounded answer would be 949.867 units squared.